So the main concepts are, first of all, the ML kit that will show you both in Android and iOS. It's slightly different. But with Firebase, you have integration, so you can use both in iOS or Android apps. And yeah, the platforms we will concentrate on is Firebase. What can you do with Firebase and what's Firebase? So Firebase, let's say, is a cloud integrated platform that enables you to use MLKit to perform actions like OCR, face recognition, barcode scanning, landscape recognition, and so on. So I will go through some of these because these will be the main interest during the labs, and you will try them with all the functions, and it will be, I think it's something very, I build the all labs, and I think it's something interesting nowadays because you use it every day. So before how it was done, you used to use Google Play services, you used to go on this page, you used some Google APIs for Android, and you used to declare these classes and use them in your project, whatever. But nowadays things are getting much easier, so we do not use anymore these let's say integrated platforms. What we do use is, as I said, MLKit for Firebase. So basically all the tools you need that are already integrated in Firebase, you just need to import your API, and later on you will see some TensorFlow inside your project, and you will basically have already the model trained, so you don't need to do any training on that. So one of the first feature I built in is face detection. So the cool thing is that it works offline and online, but of course offline is the thing. And what it does, basically it gets a picture, nice picture. It detects first of all bounding boxes of the faces. It can detect landmarks, so where like eyes, mouth, and nose are, and all the important points of the face. And some profits, so if you want to, let's say, put some, small faces or designs something on top of the objects, you can do it. So basically I took this from the web. So basically suppose that this is the input picture you take. The training that the Firebase does is basically taking for each face detected. So here you see that it says 1 of 3 because it can detect 1, 2, 3, this one is not visible. It takes bounding polygon, it takes, you won't see that this is like backend, but this is what actually is happening. It takes some facial landmarks, so where is the left eye, where is the right eye, the bottom of the mouth, and some probabilities that you know if you did some machine learning courses, it gives the probability of recognizing that the smiling is actually smiling. So recognizes that this is actually a smile. I took this demo by Rebecca Franks, she's actually an Android developer. So basically what I was saying to you before, with this library I'm able to boost whatever kind of designs. If I say I just want to cover all the eyes of the persons and all the mouth, and I want to copy paste this kind of, let's say, small designs, it automatically recognizes them through face detection, and it automatically patches whatever kind of thing you want to put on top. Just to show you how it works. On top of that, you will see landmark detection. So basically, I take the Eiffel Tower, and I want to know there is actually the Eiffel Tower in a picture. So what I do, this is just an example, but I took it from the web, and this is Bruges. So basically, what it gives as a result, you give as an input the picture, as you will see in my lab. It will give a description, so it will try to recognize which is the city represented, some coordinates. This is just a simple ID. You won't see the bounding polygon of the image, and the confidence score, just to see how high is the percentage that this, which is the probability that this is actually Bruges or not. In a demo, always took from Rebecca, here is just a simple app, it's similar to the one I developed, similar, and this is the one you would see in Android, more or less. So here is actually bounding a box through the Statue of Liberty, and it gives landmark Statue of Liberty with a high confidence. In this case, it recognizes the New York through just this simple building. I wouldn't have recognized it, but the confidence, as you see, is lower, but it recognizes that this is actually New York. And this is Turin for Italian people, just me, I think. So, no, not 2, 3, 4. So the confidence is still low, but just through this building, it recognizes that this is Turin. So as you see, what you are going to build is just a simple app that takes as an input some pictures, and on top of the picture, what you're going to do is to perform these labeling features. Then, as I was saying, you have image labeling. So, for example, if I give you as an input this picture, and I want to ask you what is actually happening, here, what I put, and this is something it could be asked in the exam, so if you want to take note, I have the description of what is happening on device, and I have the description of what is happening in the cloud, as Firebase provides both on device, so local, libraries and usage, and on cloud. I will go through explaining what is the only advantage the cloud has, that is actually precision. So as you see here, the on-device just gives me stadium. So it just takes this, and it says, okay, you want to know this is a stadium. And what it does, it gives a confidence of 0.92. If you go on cloud, but to go on cloud, you will see that on Firebase you need a specific subscription, but as it's on use, if you do the subscription, the first month will be free, as you will use a very small amount of data. Here, the description is more precise. It says it's a sport venue, and the confidence of that is higher than this one, so it's 0.98. So you will go, in my example, you will have some text, normal text in many languages, and you will see that the text in Arabic is not recognized by the on-device text recognition, that is the same as image labeling, but if you use the on-cloud, it will recognize it. So what you have is actually precision, and this is the advantage you will gather. This one, you won't use it, but of course, you get some, let's say, barcodes or QR codes, and what it does is basically, this is a simple receipt, it gives you the corners and the raw value, so it's able to read the barcode, or in this case, as this was a QR code used for connecting to a Wi-Fi, what it does, it gives you the raw value, but it gives you also SSID and the password of the Wi-Fi. In this case, it's 1, 2, 3, 4, 5, but imagine that you want to try it for a real, on a real, let's say, QR code, you can gather this kind of information, and it gives you the type of the network which is used. To do all this, well, I will explain you this later. We forget about the code now, as it's already something that you have inside. I will go through the explaining later. So basically what it does is, in this case, it gets the QR code, and in this case it just gives you the link where the barcode is actually pointing you. In this other case, it's going through some values that have been put inside, and in this case it's always a link to a project. Whereas in this case, yeah, you're able to specify even this was like a Google search results, and you are able even to specify which of the barcodes resulted you want to analyze. Just to show you that this is very practical, as it is the analysis is very, let's say, fast, and you're able to even select which of them to analyze and to get data from. In the end, what we have is OCR. I think you know it. So if you have used, let's say, you want to do a scan of a PDF and you use an app on the phone, what it does, it gets the PDF, and then with the OCR it analyzes the text as if you want to modify it and if you want to recognize the words. So as I said, let's say that we get whatever menu, and the objective is, let's say, just to recognize what's written inside. As I said before, there are some advantages if you get the cloud on top of the local. So locally, the first advantage is free. You have, this is the ideal use case, I just put it, just as an example. And as you see, the difference is this. As I said, for this lab, you can use the cloud, as you see is free for first 1,000 users of this feature per month. So you can just subscribe, use it for the lab, and then unsubscribe, and you will be free of charge. The reason is that you get high accuracy text recognition, and the document scanning quality is much higher. On top of that, in Firebase, we will see that you will use this Cloud Vision API, and I have a small demo to show you in the lab, and you will see it even in the documents I gave to you. And as I was saying, the language support, this just takes, the on-device just takes Latin characters, but if you get the cloud, it gets a more broader range of characters to recognize, and on top of that, even special characters. This we will see it later, it's just code. So basically what it does, you get a menu or whatever image, and this is just trying to get on top of that what is actually written. Not always the confidence level is like very high, like 0.92 from 0.90 on. Sometimes you will see that some words will not be given. but you can try comparing it with the cloud, and you will see that in the cloud, whatever is in the image is taking as precisely as it is, even though it's an asterisk or is a special character, you won't have problems. In this case, for example, you see it took an R that is not even here, so you can get errors. But for the use you need to do here is quite good. This one is a more advanced topic. You will have to import in my project a TensorFlow model I built just to use it as already trained model so that you don't go through the training of the model. With TensorFlow, what you could do is actually trying to build, you will have TensorFlow Lite in this case, but what you could do is actually, and there will be questions on that, just spoiler. And so if my question is, I would like to know what kind of chips I was eating in this case. So the process in TensorFlow is this: I take some training data, I put them in this library that is just a folder of images. In the folder of images processed, I retrain it with some new images, I optimize it for a mobile app, and I embed this in the app, and it's even stored in the Firebase, whether I'm using TensorFlow or Firebase. Of course, when you go to use the app in your model, the app uses it. So in this case, for example, the training data could be other kind of chips, just train it, and this could be the chips I was actually looking for. This is actually the export to images using this library. You won't go through it, it's just to explain you how it's done. You have the folder of all the images you want to train the model with. You can build a simple script to retrain the model with your script so it gets more and more intelligent, let's say. You go through the optimization for mobile, forget about the code, I'm just explaining the project. And then if you're interested, you can watch these code labs, are very interesting. You can insert into the app, declaring some strings, and in the string you put actually the TF-Lite model. In this case, you already have I provided you with the TF-Lite model, so you just have to download it from my folder. In the lab there is the link, and you just import it into your project. So in this case, well, this is the guy who did the project, but yes, in this case you see, which is the time frame it recognizes that these knickknacks were the ones that he was eating. I won't go through this, but if you're more interested, the slides are online. So this is actually an explanation of whether an update for the same model is given, how you can update your current TensorFlow model. As you won't need it through the lab, and I want you to be free, I will just stop here and I will go through the iOS machine learning kit. And if you have questions on the next slides, there are just 4 more slides that explain you how to train again the model. And if you have questions, please ask. So what about iOS? So iOS, generally speaking, if you don't want to use Firebase, it uses CoreML, and CoreML is now at the version 3, and it's actually a framework that for you who have an iPhone, actually, who has an iPhone? Okay, can you give me a very simple example of a everyday use machine learning feature you could think of? The easiest one, yes.
Just when you're in the photo apps, then you can see all the faces with your eyes and sort it. So
yeah, even easier than that.
Face recognition.
No, much easier. Okay, the first one is correct. The one of the picture, yes, I was going to show you, but easier than that. When you type a message and you see the prediction of the word you're actually typing, this is a use of CoreML, and the same is done on Firebase in a less advanced mode, but I will show you how. So as he was saying here, you can select the people in some pictures, and automatically iPhone will divide them. This is actually even done by Google. How? If you take Google Photos and you just type your name, it will just filters out all of your pictures through all of the albums. The second example, as I said, you're writing a message, iPhone and even Android, but iPhone already gives you some word based on the training of all the messages you've been sending, based on even to who you're writing to. And then for those of you who have an Apple Watch, the same. So if you want to answer to a message on top of Apple Watch, it will straight give the same suggestions that the keyboard is giving. So in the whole iOS world, Apple world, these are all the features that CoreML provides the user. Not all of that are present in Firebase, or if you want all of them, you will need to have a premium subscription. And the nice thing is that all of this is embedded in the model, so you don't have to do, the user doesn't have to do any specific modification. And if you want to download any specific model, you just connect to the developer account and you just download the model depending on the tasks that you want to do. Why? I will go through a simple example. So my task here, and you will see that there are similar ones, is I want to show all the images representing roses. So if I want to do, suppose that machine learning doesn't exist, if I want to do it by code, what I would do, and this is actually what I imagine, I would do this. First of all, I say, if the color is more or less equal to reddish, it means there is a rose. But as you know, it's not complete, because the rose cannot be just red, can even be white, can be even other colors. The second thing I would think of is the shape. So I could say, is shape equal to, what's the shape of a rose? So you don't know. So what you understand is that the training of this model, using TensorFlow, whatever you want to use, is very difficult. That's why we train data using these libraries. So how does the training works? The same, you get offline training, so you have some pictures, plus some labels to represent, to show that this, for example, is a red rose. This, for example, is not a rose anymore. So you get training data, you train the model, you have an algorithm that is actually the learning algorithm that CoreML works with, and then you get to a model. The model you can train both by yourself, in this case, or you can get already the existing model that you already embed in your app to get it trained. You have some inference on the model, so you have some assumptions to do on the model. Why? Because you need to get some result on the picture or on the object that you're actually analyzing. What happens is, in my CoreML, I take the picture, I got a model, and on top of that, I have a label, that is the one that has been given in the training data, and I have a level of confidence. 95%, we are quite satisfied with that, it means there is actually a rose. To do this without any machine learning libraries, what used to be done is to create models like this. You cannot even read, but actually it was more longer than that. I took it from the Apple developers' deprecated libraries. And this was actually how a convolutional layer to specify some kind of kernels and sometimes on convolutional layers on top of that was used by a developer in order to define a model, in order to define what kind of inferences to be done on an object. And this, of course, it's challenging and is not done anymore. So the challenges of nowadays are the correctness of the analysis, the performance, and the energy efficiency. So the framework that machine learning uses is these ML frameworks. So you have basically your app. On top of that, you have some specific frameworks. So this is a library we're going to use it today. So it's the Vision library. You have some NLP that is used for natural language processing, and you will see it even today. On top of that, you have the ML framework. So this is the CoreML, but it's the same level as Firebase works. And then you have some performance primitives, accelerated MTS, but you're not going to see that today. So just to see how in practice the framework works, you can use it for object tracking, for example. So in this case, it's actually recognizing some fruits that actually are represented in the picture. Or as I was saying for Android, you can use it for face detection. And you will see that the only thing is the speed and the correctness of the algorithms, but to use it, you will of course need it a lot more of training compared to Firebase. It's much quite easy to use Firebase, that's why we prefer this solution, and even for timing. Natural language processing, why? You get language identification, so you just provide a message, and libraries you can say which language is actually being used. Some entity recognition, so you just provide a picture and you can say Pablo and I are back from Finland, so the place identified from this picture is actually Finland, from the plural thing. And on CoreML, what you do, and this is actually something I used, you can provide some kind of audio, and some processing can be done to recognize which kind of musical genre it is. So in this case it was just a rock, and you get it printed. Or some image captioning. This is something you're going to use today. So you get the image, in the app you would see that you can select through 5 images that I put you as default, but I will explain if you want to put some more how to do it. And you will get some pictures with something happening in the picture, and the objective is just to follow the instruction. It's not something you need to code. The all instructions provide all the code, so it's just for you to play with it, and maybe on top of that build something new. So I already tell you that in both labs you're not asked to build me the code to do this. Maybe on top of an already existing code, you are asked to build something similar but not completely new. And then this is just restricted from Apple, just publicity for Marvin. It's just, this is the latest chip that is used for this kind of high performance and for inference in this specific.
A13 now?
Yeah, no, this is because I took it from the WWDC 18, but yeah, now we are in A13.
A13.
Yeah. If you...
There's a question there.
Yeah.
So when we use machine learning in Android or iOS development, so we use a model that have been already trained.
Yeah, it has been already trained.
So can we use our own data for training some random?
Yeah, you can use. It's not a process you get very. It's not a very at ease process, because in this case, what I knew is that you would have had at most 2 sessions to do this lab. So in order, but yeah, of course you can do it. You will see that the only thing that it changes is that you have a TF Lite file extension, and that one is the file you extract from whatever machine learning algorithm you use to train data. And this is the one you're just going to provide to Firebase, because Firebase at a certain point it says why you want to use machine learning libraries. You can say all the functions, or you can say natural language processing. In that case, it will just say, do you want to use an already existing model, or you want to use yours? If you want to use yours, you just upload yours.
Okay.
Cool.
Is there some adaptation between programming? Because in Android and iOS we don't program with Python, while in machine learning usually we use Python to do our models. So can we do our own model with Python
with Firebase
and try to upload?
You can try to do it, but Firebase I will show you in the lab. It has already some built-in functions that permits you to download a model that you can you upload the model to Firebase, and then the Firebase already adapts it both to Android and both to iOS. If you have the premium functions with Python, yes.
Okay.
Also, usually you don't train or create the models there. You create it, for example, with Python. You create when you're done with the model, then you upload it.
Yeah.
Okay.
It's offline process.
Yeah.
Okay.
Right?
And if, for example, asked what's on top of that, what's behind the running on the device, the reasons are actually 4. So first of all, user privacy, cost of data in doing this kind of analysis, cost of the server side, and of course it's something you can always use and you can always contact. So this is actually an example I took from the lab. It's not a photo you will see, but it's something I tried myself. So here is able to recognize that in this picture there is a dining table. Here it gives you the percentage. Actually, I was not able to, I didn't took the video, but actually what was happening that I was able to create an app. It was just with the camera on. Wherever I was going and stopping on one object, it was recognizing live which was the object with the level of confidence. So this is something actually you can do, and it's actually not so trivial with an already existing library. I won't go through this. I will just explain you something related to, well, this you already know. There is a well integrated model. You have the model that is already communicating. You have the focus on the experience by Apple when you're trying to enable these kind of features. And yes, the privilege is compared to Firebase that CoreML is even more simple, performant, and compatible. Why simple? Because as you saw, you have some APIs that are already integrated, and if you use Xcode, you get already all these APIs inside. That will work very slow because you're using a cloud Xcode, but locally it's much faster. Performant, why? Because the engines that use are very performant and always accelerating on top of the model, and you won't see it, but there is even another library, another framework on top of that is called Metal. That is actually a new framework that is enabling the acceleration of these libraries. Compatible, why? Because it's public and you can use it for multiple training libraries. The model, we saw it, how it works. So you get a picture, you want to know flower type, so you need to get some functions that are learned from data, you need to observe some input, and you need to predict what is actually going to happen. And some of the most existing and most used functions are this, so sentiment analysis, some handwriting recognition. Not all of them you will be able to see, but for example, if in a picture of me smiling you want to understand which is my emotion in that time, you will use some libraries of sentiment analysis, and Apple will actually, the CoreML will actually enable you to get the precision score on top of an emotion the user is actually proving in that time. So yes, if you get a sentence like that was totally awesome, you get some corresponding result. Or if you want to classify a picture, or you want to predict some text, yes, this is what you are going through. On top of that, you will see some of the, well, this one is too advanced, but let's say that all of this is already in the model you will go through. Let me just explain you where this model comes from. So basically, these are some models that has been taken. I took some screenshots from the developers of Apple. So the thing is that if you read this and you think this is very interesting, so detects the scene of an image from 205 categories and blah 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 blah. But you just want to, you see it's interesting. You want to just include it. You have the possibility, even though you're not a developer, to just download it, include it in your app, ship it, and use all of the functions that the model is actually providing. So easy, yes.
Quickly do this type of download runtime.
The problem at runtime is that you could do with CoreML, but you cannot do it with Firebase.
I see.
So if at runtime you do this kind of download, what can happen is that basically you could have problems because downloading it at runtime, it prevents you to actually have the possibility of selecting where and when you want to use it, because you actually need to download it, copy it, and this will actually lead to maybe not problems using the app, and maybe for sure in problems with the battery and the efficiency, because actually every time the app, the user runs the app, at runtime the app will say which model you want to download. So both, either you specify the model or either you provide the link where the model is, but for sure, like every time at runtime 40 megas of model, you will need to specify some methods.
No, but the question is, probably the models get updated over time. So you
Yeah,
update the application.
with CoreML, if you download the model, it's like it's like a Git. Let's say if you download the model, Xcode recognizes already as an existing model. You have the possibility of updating the model over the web as a developer, not as a normal user. You have the possibility of updating the model without connecting to the web page every time. You can just update the model with the old updates that they come. It's just a library in GitHub.
Correct, but then if you want to update the model, you need to update the app.
You need to update it in the app, yes. So you need some method that, with the existing model inside, is actually able to update. So the difficulty here is basically you have an app that does something. Sometimes it can happen you update the model, and then you have some discontinuing functions between the creation of them. So it can happen that sometimes you need to even go and modify the code.
Because there's a similarity I see, it could be like in Android in-app purchase. Like
Yes,
you
exactly.
on the fly,
You are able to download.
you download, you put things, and you build.
Yeah, exactly. And well, these are some of the popular communities that uses this kind of libraries. The integration, as I already said, CoreML already provides tools that from a Python coder are able to interpret them and put them into a library. So basically, what's the relation with them? You have some communities that actually brings it to some tools that are already built in CoreML and build an ML model, and on top of that, it's open source. So I would just explain this. That is what you are interested in. So as I said, same for Android. You have MLKit on top of that. It's both iOS and Android. And this is actually the schema of MLKit for iOS Firebase, which are the APIs and functionalities it gets. You will use, first of all, Cloud Vision API, that is from Google. You will use TensorFlow Lite, as I said. You won't use Neural Network API, but this is something already built in too. And for the question I was saying before, this is something it interests you. So differences in iOS between on-device and cloud functionalities for Firebase. So as you see, landmark recognition, image labeling, and text recognitions are more or less the same. The only one that it really matters is in landmark recognition is able to get some more accuracy, and you will see even in text recognition, but it's actually similar. But landmark is the one really cloud is the useful in case. So what you will see in the lab is something like this. So suppose you have your project built. It's the same for Android and iOS, that's why I put it together. You will have first to, I introduced a new concept. The new concept is called Cocoa Pods. So as I built the library, as I built the project, there are some libraries that were not included. So in order to include some external libraries in an iOS project, on an iOS, let's say, repository, what you do is you use Cocoa Pods. There are external libraries you can use at runtime. So if I want to share the project with you, what you need to install is you run your terminal, and there are the nodes already in the lab, but you run your terminal and you install all the dependencies from Firebase, because in an iOS project you will see that the Firebase is not included in the same time in the same let's say way as in Android. So you will have to install it from external dependencies, and in order to do that you just have a pod file, and you will just do pod install in the home folder, and this will install all the compatibility with Firebase. And after that you will go through your project, you will do get started, and you will enter to a screen that shows like this. It's the same. So here what you have is all the APIs from MLKit. So whatever is the functionality or API you want to use, you can click on that and it will give you all the instruction on how to include it. Or what we will see is that here there is a custom. That is actually what Sidadi was asking. So basically, if you have your own model already trained, you can click on custom and you will update your own TF-Lite. That is what actually you are going to see today. What I would say is that I'm done. I wanted to show you some code, but I think it's not. We don't have time. The only thing that is the thing, I don't know if it works, that you could do, as I'm really interested, is to have some feedback. So if you're able to scan it, just on whether it was clear, whether you had some problems, you can write whatever you want. It's just to understand which problems you get through the labs, just on these ML labs. So as soon as you do it, as you have the slides, you can just click on the last slide and take a look at there are just 2-3 questions. You will just do 30 seconds. And if you don't have any other question, I would say for me.
Should we go through the instructions?
Yeah.
Quickly,
Okay.
So you have a choice, as I said, either you go for Android or iOS. Just one is enough.
So labs, iOS, and then okay.
But in the exam, it will be questions for both of them, Android and iOS.
So last year there was
one question.
last year there was one question on machine learning for Android.
Mm-hmm.
So basically you were asked to describe first of all what is MLKit and what is actually TensorFlow Lite, why you need to use them.
Mm-hmm.
And on top of that you were asked, as I already said, which were the differences between on cloud and on device. So basically I would say that for sure the MLKit are just generic, but I mean just as it's a very actual topic, it's interesting.
So maybe we do it platform agnostic question.
Mm-hmm.
Right? Something that realistic.
So, okay, I apologize already because the lab is, it seems very long, but it's actually not. I know that Javier that went already solved it, so that's why I asked for feedback, because it's already new from me. I just wanted to know if there were any problems running it. But he said that there are no problems, so you shouldn't have. So what I say here is, okay, you have the introduction, I already said, okay. So this is the output if you want to do the iOS one, of course. The final objective is you will have five pictures, and you will have four, let's say, APIs to use. The difference is that I just put the find face with contour, that is with the local library, and this is find text with the cloud. I just put into parentheses because it's an optional one. It's just if you want to subscribe just to try the functionalities. So yes, here you're actually taking all the contour of this actually lady represented. In this case, this was the case I was telling you before. If you do this analysis with local text recognition, it will just recognize do not feed the birds, because this is in italics, in Latin. And all these Arabics, or I don't know which language, maybe Tunisian, I don't know, Arabics, would not be recognized. If you use the cloud, you will see that this is actually all taken, and in fact, this is the output from the usage of the cloud library. So the most important thing is this. So to start the lab, what you will be asked, and please follow this because maybe if not, you will have many problems, and I know then you will start asking like boom. So this is. So the old code is on my mega folder. So clicking here, you will download the old code, from which you will start building functionalities. What I say here is I explain everything very clearly, and then I say that for later, so this is the folder you will start from. So there is a folder inside this, starting code, there is vision, and then there is starter. So it's called starter because that is the code you need to run on your Xcode. On top of that, later, you will use it later, but here you will have to download the TensorFlow Lite model, and this is already trained, so you will just need to import it, and there are all the instructions. What is important in order to not, and this is, as you see, the format of the file. On top of that, yes, this is, you create the project, this is to set it up. To add this, you need to add this. That of course I didn't add it because it would have run with my preferences and it would have given you an error. So you will follow the Firebase instruction and you will see where precisely you will need to add this file. So this is the important part for those of you who don't know it and have no clue about it. So I explained what is CocoaBots already. And it's actually, let's say, a group of libraries that you need to use if you want to include Firebase in this case, but other libraries in other cases. So here you have a screenshot of what you need to do actually. So this is my own terminal. So first of all, you will have a text file that is called pod file. In the pod file, what you do is actually you specify which are the libraries you need to use. And in this case, you need to specify these ones. So you will have just platform, comment the next line, okay, use frameworks, and the target. And so this you will need to add it. And why is that? Because of course we will need to use all these Firebase core and vision APIs. When you finish editing this, and you can just do it with a simple editor, you install it, where you just go into the starter. As soon as you're done with the file, you save the file and you click pod install, and this will simply install. I didn't put the screen, but this will just say installing. When it finishes the install process, you will open a file called MLKit lab 5, I don't remember the name, .workspace. You won't open any Xcode file, you will open a workspace. Why? Because when you build a project with external files and you run pod install, this is the one that will create the project on which you will work on. So the workspace is an Xcode project with the already built-in libraries and dependencies that you built in the pod install. Apart from that, it's actually very easy. I just put all the steps. It's not there's nothing difficult. It's just for you to know how to use them. There are even some, let's say, parts in which I say if you get this error, just solve it doing like this. Okay, you run the app, you should get the same thing. So this, for example, is the text recognition. You will get the same exact picture, and with find text, that is the first function functionality you will enable. You will just recognize the text that is there. some questions. So I ask in this case, can MLKit for Firebase be used for handwritten text? It's just for you to know based on the theory that I gave today. And yeah, maybe there are just two in this case. One more, let's say, a little more advanced if you're curious, and one more easy, but actually it's just for you to know that you got there. This is the same as before, so as you see with find text, you will just see the normal text and not the other one. This is face contour. And of course, the code is all divided in sections. So you will see that in the main code, I already put sections like face contour, text identification, so you don't get confused. This is Swift, actually not Swift. Process detector. Okay, some last questions. Okay, so this is the real work you may have to do. So here, for example, I declare some contours on the face, and here I declare one contour of type face. So this contour, if it's a type face, it means that it will just get the contour, the circle of my face. It won't get anything else. What I ask you to do is there is actually, I already commented the missing parts, to recognize all the other parts of the face. So it means eyebrows, eyes, lips, and nose. I already give you the library, and it's similar to this, so it's not trivial to understand. It's actually really straightforward. Here you will get to the point where you will need to import your TensorFlow model. So it's already trained, and here are the steps. You just go to your Firebase console, and in the TensorFlow section, you write add custom model, you browse, and you just import the file I give to you. And here, as Navid was saying before, I configured the app that automatically downloads the model. Not at runtime, but it automatically does it. You will have some model manager, model interpreter that are actually the classes and the functions that actually enable you to read and analyze the model. Here I have some new code. The code is in Swift 5, so you shouldn't have any problems at all, I hope. If not, just drop me an email if not tomorrow, or if it's today, just ask. And I don't think there is nothing else. Maybe, yes, this one, the last one. This is the real app, this is a picture, and this is the results that you should get. So you will implement this kind of screen here. That is the one that will pop up saying, in this case, it needs to print tennis ball and racket with the level of confidentiality. It's here, but you cannot see it, but it's there. Here, the ones in red are possible errors you could get, or maybe explanation you really need to give. So in this case, so if you see the error total size of this actually an error I got, I ask you what's actually happening, fix the problem. And finally, yes, this is the optional part. If you are interested, just ask me. And what I wrote is that this feature requires the Blaze plan, that is actually the premium one, but we're not going to see it. And on top of that, I hope you enjoyed the lab, and you can give me some feedback, as I really spend a lot of time in doing it, but I hope you will enjoy. And if there are no questions, the Android one is completely the same, but they're just different features, and functionality is still the same. So thank you very much.
There are slides about Android with this kind of instructions too.
Yeah, completely updated. Cool. Thank you very much.
Okay, so then if no questions from Bruno? No. So let's go to the lab room. Right?
Thanks Bruno, grazie, bravo, sei un mostro.